Hi everybody, welcome to the shop. I'm Gerald. Today we're going to be revisiting problems using f prime and f double prime and how they relate to each other. This video would be relevant to you if you're in AP Calculus in high school or college level Calculus 1. If this video helps you and you like the content, please like and subscribe to the channel. Let's get started. Okay, we're looking at this function, f of x is equal to x to the fourth minus 4x to the third. And the problem is to sketch the function. Okay, now what we're going to do, if you haven't watched the previous videos on f prime, and f double prime and how they're related, please go back and watch those. Now underneath that yellow sheet, I have the function graphed. Okay, but let's see if we can analyze it and get a decent sketch of what this thing is going to look like based on what we know. So here we go. F of x is equal to x to the fourth minus 4x to the third. So f prime of x would be equal to 4x to the third minus 12x squared. Now I can factor that, so I'm going to do that right now. If I set the derivative equal to 0 to find the critical points. Now remember, critical points for a function are where the derivative is 0 or where it's undefined. But since this is a polynomial, I don't really have to worry too much about where it's undefined. So I'm going to set the derivative equal to 0, and that would mean that that's going to be 0 when 4x squared is equal to 0, or when x minus 3 is equal to 0. So when I solve these two equations, I'm going to get x is 0, and I add 3 to both sides on this one, and I get x is equal to 3. So right now, my critical points are 0 and 3. Just let me write them up there. Now let's take care of f double prime. So f double prime of x. Well, I'm just differentiating f prime now. So that's going to be equal to 12x squared minus 24x. And now what can I factor out of this? So I guess I can get 24x minus 24. And I'm going to set this equal to 0. Now, I don't want to say these are critical points when I find them because, the textbook defines those as zeros and undefined points on f prime. But these are like critical points for f double prime. And if you remember, we're interested in those because we want to find out where the second derivative is positive and negative so that we can find where the function's concave up and concave down. And where it changes concavity is called the point of inflection. So when I solve this, I can factor out a 24, and then I have left inside x minus 1. That's equal to 0. So when I set this, I set this equal to 0, it's going to be x minus 1 equals 0, so therefore x equals 1. So that's going to be the relevant point for the second derivative. Now let me just, now that you have this, let me just shrink this down a little bit so that I can draw the grid. All right, so here we go. Now the grid for this function. All right, we're going to grid f prime, and we're going to grid f double prime. Now the critical points for f prime were 0 and 3. And also I'm interested in 1 for double prime, right? So I'm going to put the 1 right there. Now, if I look back, just kind of look up back towards the top of the screen, we're going to grid f prime, and I'm going to look at f prime as 4x squared times x minus 3. And I'm getting that from right there. Now, let's do the regions that we got. For f prime, right, I'm going to put in something to the left of 0 and see what that is. So if I put a negative number in for x, well, 4x squared is going to be positive no matter what. And if I put a negative, say for x here, I put in like a negative 10. Well, negative 10 minus 3 would still be negative, so that's negative. So what I know is the derivative is negative on the left side of 0. Okay? Now, let's put a number in between 0 and 3 and see what we get. All right, so if I do that, if I put in a number that's bigger than 0, like let's say I put in 0.5. Well, like I said before, this is always going to be positive. And then if I put a number smaller than 3 but positive, if I put that in for x here, 0.5 minus 3 is going to be a negative number, and a negative times a positive is still negative. So all those are still negative. Okay. Now you could also say, since this is the root and the x squared, the x term is squared there, it's going to be a bounce root, so you knew it wasn't going to change signs. You can do it that way too, but I'm just going to go through and look at all the regions. All right, now I'm going to put in a number that's larger than 3. Okay, so if I put in a number for x that's larger than 3 for the derivative, like I keep saying, this is still positive. But now if I put in a number larger than 3, like 5, this will be positive too. So now I know that I have positives to the right of 3. Okay, now let's contend with f double prime. So now for f double prime, I'm going to get that from right here. Okay, so we're going to look at 24 times x minus 1. Now, as far as f double prime is concerned, we're really only interested in its critical point, probably a bad term to use, but I'm going to use it anyway, of 1. So let's see what happens to the right of 1 and to the left of 1, and let's grid all that in. So for f double prime, if I put in something to the left of 1, like say -5, 24 is always going to be positive. I don't have to worry about that. But -5 minus 1 is negative, so I know everybody to the left of 1 is going to be a negative number for f double prime. And then if I put in something bigger than 1, now if I put in for x, if I put in like 4, okay, 4 minus 1 is positive, so now it's going to be a positive times a positive, and now to the right of 1, that's going to be all positive for f prime. So now let's look at this. Let's go through and actually sketch what this graph, is going to look like. So the way I like to do it is I say, okay, as far as f prime is concerned, this tells me that f is decreasing to the left of 0. Between 0 and 1, it's still decreasing. Between 1 and 3, it's still decreasing. And then after 3, f is increasing. Now, as far as f double prime goes, let's put that in. To the left of, and I'm going to break this up into, to the left of 1, I'm still going to, you'll see what I mean. It's concave down here, and it's concave down here. And then after that, it's concave up, and then to the right of 3, it's concave up. And now all I'm going to do, I'm going to scroll up a little bit. I'm just going to sketch what this curve has to look like. We'll do that in like a green color. So to the left of 0, we're decreasing, but we're concave up. So that's got to look like this, right? Now at 0, I know I have a 0 derivative there, so I know I kind of flatten out. But then it says I'm still decreasing, and I'm concave down now. So now I got to do something like that, right? And then at 1, I'm still decreasing, as right there, but now I turn to concave up. So now I have to look like that. And then after 3, I'm increasing and concave up. So now it has to look like that. So now what I have is I have the general shape of my curve, okay? And I know 0 corresponds with this flat point that didn't become a max or a min. 1 corresponds to the point of inflection, and 3 is actually a minimum, and you can see around 3 the derivative changes sign. Now if I want to know what those y values are for that, if I want to know what those y values are for the function, okay, well, I can go back to the original function, and if I let x be 0, y is also 0. So I know this point right here is 0, 0, right? And then this point, x is 1, so if I plug that back in, I'm really going to get 1 to the 4th minus 4 times 1 to the 3rd, so that one's going to be 1, -3. And if I plug 3 in for that minimum point, when I plug 3 into that function, I'm going to end up getting -27, okay? And then, so that, because when I just sketch the graph, I don't really know exactly where it is, like shifted up or down, but I do know what it looks like. Now, I'm going to move the yellow sheet and let's see how we did, okay? So let me get this out of the way, pull that down, and there you go. That's what the function looks like, which is pretty much shaped like ours, okay? You have the flat spot there around 1, you get the point of inflection where it's first it's concave down, then it's concave up, and at 3 you got the minimum. All right? Okay. Now, I got another one lined up, which is here. Now, sometimes you're going to be given a picture of f prime. That happens a lot on the AP test. They'll give you a picture of f prime, and they'll ask you all kinds of questions about f. So we're going to do this the same way. So we're going to get a sketch of what f would have to look like. And let's just do this now. Now, I want to point out, the problem has to tell you that f is continuous on the interval that you're talking about. F prime's not. That means the derivative doesn't exist in certain places, and that's fine. So let's see what let's look this through. Watch. So I'm going to draw my grid, And as always, I'm going to grid F prime, and I'm going to grid F double prime. Okay? Now the relevant points to me, it starts at A. We know we got B, we have C, something's going on at C, and then it ends at D. Okay? Now I want to point out, B and C are critical points. The derivative is 0 at B, and the derivative doesn't exist at C. Now let's put this grid in. So from A to B, remember this is F prime you're looking at. F prime is positive. It's above the x-axis. So from A to B, F prime is positive. From B to C, for the same reason, F prime is negative. And then from C to D, right, F prime is positive again. And I want to note it's constant, okay? Okay, now let's put in F double prime. So from A to B, F prime is decreasing. So that means its derivative, F double prime, would have to be negative. So there it is. Then from B to C, F prime is still decreasing. So its derivative, F double prime, is still negative. Now then from C to D, F prime is constant. It's not really doing anything. So I'm just going to kind of leave it out there, because what I know that means is that F is going to have a constant slope, which means it doesn't have any curvature. So as far as I'm concerned right there, I can't really put in any signs. I guess I could put in zeros there, but I'm just going to leave it out. All right, let's look at what happens, okay? Let's make a sketch of what this would have to look like. So as far as F prime is concerned, F is increasing there, and it's decreasing there, and it's increasing there. As far as F double prime is concerned, that talks about the concavity for F. So I know that F is concave down, and then F is still concave down. And remember at B, since the derivative changes sign, we're going to have a critical point. So what would that look like? Well, let's draw it in green. Increasing in concave down, that would have to look like that. Then decreasing in concave down, that would have to look like that. Okay, so that point corresponds to B at that maximum. Then what happens at C? Well then, all right, so we know we're concave down. Now remember, the derivative doesn't exist. Now there's two ways the derivative cannot exist if you remember back when you first started learning about the derivative. You can have like a vertical tangent line where the curve like curves up and gets vertical for like a moment and then goes back down or something like that. Or you can have something like a sharp edge. All right. Now let me know in the comments if you want me to explain why that is. But right now we don't have a vertical tangent. It's not like this is going to infinity around here. What we're going to have is a sharp edge, because what happens in this case, well, as you'll see over on the graph, right, we're decreasing, and then suddenly we're increasing with no concavity, which means we're increasing linearly. So this curve abruptly changes from that to that. And notice this is a linear graph. It's a straight line because it has no curvature there. And the derivative is positive, so it's got to be increasing. So this function would have to look something like that when I graphed it. Now again, I don't know if it's like that. I don't know if the graph is shifted down. I just know what its shape looks like. And I know that B is a maximum, and technically C is a minimum. All right, so you got to be careful when you're looking through. All right, hey, that video is starting to get a little bit long, so I'm going to stop it there. If you want to see more of these problems worked out, just please let me know down in the comments, all right? Have a great day.